Hey everyone, today we're going to continue on with our discussion of composition of functions. So just a quick recap of what we wrapped up class with yesterday. Remember that when we are doing composition of functions, f circle g of x means f of g of x, which means wherever in the function f of x, wherever there is an x, I'm replacing it with the function g of x. So that entire function is getting substituted in for x. So I have 3 times x squared minus 2x plus 6. And from there, right, if I just distribute, I end up with 3x squared minus 6x plus 18. Oops, and I forgot my minus 4 on the end, so then it's minus 4. And so my final answer then would be 3x squared minus 6x plus 14. So that would be the composition of f of g of x. We also said yesterday that g circle f of 1, once we found g circle f of x or g of f of x, we could substitute 1 in. Right? This is the same as g of f of 1. And so you could find the rule for g of f of x and then substitute 1 in, or, which I did not talk about yesterday just because it was the very end of class, we could actually just start on the inside and work our way out. And what I mean by that is this. We can find f of 1. F of 1 is just 3 times 1 minus 4, so that would be negative 1. And then I can take that value and substitute it into g. So now I can find g of negative 1, which would be negative 1 squared minus 2 times negative 1 plus 6. So that would give me 1 plus 2 plus 6, which would give me 9, which is what we got yesterday when we found the rule for g of f of x and then substituted 1 in there. So I just wanted you to be aware that that's another way you could solve that type of problem. But I want to move on and talk about excluding values from the domain of f of g of x. And this really only comes into play when you have an algebraic expression, meaning some fraction with a variable in the denominator. So if x is not in the domain of g, it must not be in the domain of f of g, because g is this function that we're starting with. That's what we're inserting into f of x. I have to first look at the domain of that, and if I have to exclude something from that domain, then it has to be excluded from the entire domain of the composition. Second part, any x for which g of x is not in the domain of f must not be in the domain of f of g. Okay, so let's walk through what that actually means. Let's first go ahead and find the composition of f of g of x. Okay, so that means I have 2 over 3 over x minus 1. And so that's a complex fraction. So what we need to do is we need to get rid of that complex fraction. One way we can do that is to multiply every single term of our fraction by the denominator. So I can multiply everything by x, which would give me 2x. Those x's cancel, so I have 3 minus x. And so by multiplying everything by your common denominator within that complex fraction, that gets rid of the complex fraction. So f of g of x is 2x over 3 minus x. Okay, that's the complex fraction. So now let's talk about what needs to be excluded from the domain. Go back to g of x is equal to 3 over x. So g of x is equal to 3 over x. Well, that means that x cannot equal 0. Okay, because x cannot equal 0, that's going to be one value that I exclude from my domain. The other value I need to look at is any value, number 2 here, any x for which g of x is not in the domain of f of x must not be in the domain of f circle g. Okay, so the other value then that I need to exclude is when you look at this. look at that denominator. And when we solve that, we get x is 3. So x can't equal 0 and x cannot equal 3. If I'm writing that in interval notation, then I'm going to say, well, from negative infinity to 0, union 0 to 3, union 3 to infinity. So once again, when you are excluding values from your domain, look at the function g of x first. Now that's if you're doing f of g of x. If it was g of f of x, you'd have to reverse this. So not to confuse things, but basically what I'm saying is look at that inside function first and find the domain of that. Then once you have the composition, find the domain of that. Okay, that's the idea behind it. Okay, lastly, I just want to go over really quickly kind of undoing the composition or decomposing functions. It's really not too complicated. What I want you to do is look at the function and say, hey, how can I write that as a composition of functions? Well, when you're looking at this, you could say, okay, well, I have this function that's being raised to the 4th power. So if I kind of break that down and say, okay, well, if I take some function, x to the 4th, and then I take this other function, g of x, well then I know that f of g of x is going to take this entire function here and plug it in there, which would give me that h of x. So f of g of x is equal to h of x. And really what it's a matter of doing is just kind of looking at it. Hopefully you can visually see what's kind of the inner function and what's the outer function. You can think of this as, well, it's this whole thing being raised to some other power. And when I'm doing these, it should be relatively obvious. I'm not going to give you something that's too hard to figure out that you're not going to be able to visually see it. Okay, if you look at part B here, I've got the cube root of x minus 7. You can think of that as x minus 7 to the 1/3 power, and then it looks very similar to part A. And so from there you could say, okay, well, if f of x is x to the 1/3, then g of x is just going to be x minus 7. Okay, you don't have to think of it as x to the 1/3. You could just think of it as the cube root of x. Either way is fine. Either way, you're just plugging in g of x into that. So f of g of x would then equal h of x. Okay, so hopefully that helps with the assignment for today, the rest of the assignment on composition of functions. Let me know if you have any questions. I'll see you next time. Thanks, everybody.